Hi, my name is Shahad Khamis from 10G1 in Virginia International Private School, and today we're going to talk about COVID-19 and mathematics. At first, what is coronavirus or COVID-19? Coronavirus is a contagious viral strain that can be passed from one person to another via direct contact, respiratory droplets, sneezing, coughing, or talking, touching a surface infected with the virus. But let's talk about the spread of corona in the UAE. The first case of COVID-19 in the UAE was identified on January 29. As of May 31, there were 34,557 cases. The government has taken stringent steps aimed at controlling the spread of the virus. It's shown in this graph, the total corona cases that are increasing each month. At first there were few corona cases, but then it starts growing. It is a fact that math is helping to answer crucial COVID-19 questions. Math isn't only useful for understanding the extent of coronavirus and infection, it can also help us to work out what to do about it and can also provide clues about what might happen in the future. Now I'm going to explain an example of how math helps us to predict the spread of future pandemics. Let's take this example. COVID-19 cases were first counted in the United Arab Emirates on January 15 of 2020. On this date, there were initially 5 family members reported. However, after 45 days, the cases had increased up to 8,000 cases. Let's solve A first. But first, let's talk about the general formula of the continuous exponential growth. The rule is A of t equals A sub o times e raised to kt. The A of t is the final amount. The A sub o is the initial amount. The e is normal, it's equals to e. K is the exponential rate. The t is the time. A. Write an exponential model that approximates the number of cases in the United Arab Emirates after t days. Determine the exponential growth rate k to 5 decimal points. At first, let's write our growth general formula, which is A of t equals A sub o A. Write an exponential model that approximates the number of cases in the United Arab Emirates after t days. Determine the exponential growth rate k to 5 decimal points. At first, let's write our growth general formula, which is A of t equals A sub o times e raised to tk. A of t. A of t is the amount of something you have after a certain period of time. The A is the amount, and the t is the period of time. In our life problem, we had 8,000 cases after 45 days. That means that the 45 days is the certain period of time, and the 8,000 cases is the amount of something that we had after this certain period of time. So AT is 8,000. A sub O. The sub O tells us the beginning of the process or the amount of cases at the beginning. In our real life problem, we had initially 5 family members reported at first. So A sub O is the 5. T is the time, which is 45 days. And K is the rate, the thing that is missing in our problem. At first, or the first step we need to do is let the E alone in one side. So we're going to divide both sides by 5. 8,000 divided by 5 is equals to 1,600. You can also use a calculator to find the answer. Now we are left with 1,600 and on the other side e raised to 45k. Logs will help us to find the answer, so we're going to insert the ln since e is related to the natural logs. So it's going to be ln of 1,600 equals to ln of e raised to 45k. Since 45k is an exponent and is related to the log or the natural log, we can make it as a quotient where we can move it at the front of the log. So it's going to be ln of e alone and the 45k in the front. So ln is considered as 1 and you can cross it out. So we're going to be left by ln of 1,600 equals to 45k since we moved the ln or the natural log. Now we want to let the k alone in one side to find the rate of the growth. So we're going to divide this by 45 on both sides. You can use a calculator to help you find the answer. ln of 1,600 divided by 45 is equals to 0.16395. Now let's solve B. B. Use your model to indicate the number of cases there will be on March 20, 65 days after January 15. At first, we need to write our growth general formula, which is A of t equals A sub 0 e raised to tk. In this question, we need to find the AT, which is the amount of something you have after a certain period of time. We need to find the future pandemics and the future cases, that is 65 days after January 15. So AT is going to be alone on one side. A sub 0 is the beginning of the process or the amount of cases at the beginning. We had 5 cases at the beginning in question A, so A sub 0 is 5. T is the time or the period, so the T is 65 days. The K, we found it in question number A, which is the rate of the growth, which is 0.16395. Now this step is so simple and easy. You just want to plot these numbers into the calculator to find the answer. The answer is 212,391.7896. So these are the number of cases there were on March 20, 65 days after January.